Hello to viewers, welcome to my channel Science and Technology. In today's show, Science Thursday, we're going to talk about unique internal combustion engines and sealing. That's the most important puppy. So let's dive deep into it. So what exactly is the problem? Well, we have fuel, that's cool, awesome GG, but it goes boom. And we need to basically get a work out of that boom. It's not luxurious as steam engine where you just fire it and you get steam. No, we get a boom and we have to get work done from that boom event itself. It has to be done in sync, meaning power stroke happens, you have to extract energy at that very moment. You do not, let's heat something up, let's do some phase change, let's run some turbine. No. That's why steam engines happened earlier. We had to survive this. Basically, boom event, get energy in that boom event. However, you must have paid attention to the fact that humanity had a very powerful boomy device, which we called powder charged mass accelerator, or commonly known as pew pew. So this pew pew devices, we have been developing this puppy for 2 centuries. So what did we learn? Well, we learned that basically if it's too tight, it goes kaput. It goes boom. So that's the one problem, meaning you cannot make it too tight. But if you make it too loose, it goes it does not have enough oomph. Same amount of charge, loose, too tight, boom. Just right, it works. Almost like how your normal internal combustion engine's AC compressor runs. It has a seal that actually leaks a refrigerant. Like, why? It's why it's not hermetically sealed. Well, how would you spin it without having electrical system? So how would you spin it? If it's not hermetically sealed, if you make the seal too tight, it takes too much horsepower to run. And if you make it too loose, it loses refrigerant too quickly. Exact same problem. So it just had to be right. Like, I would genuinely urge you to look into the sealing of these puppies, type high speed pew pew accelerator, and you will be shocked. Like the pattern, the gases, like some of the modern fuel systems are so good that you can see fire coming out of grooves of the barrel, not from the actual mass that is being accelerated. It is that well sealed. It is really good. Now here's it. How the heck this solved it? Well, we learned it very early, is that, yeah, you can't do this without sacrifice. So there has to be something either like a copper or brass that does the sacrifice. And be mindful, when we have something that sacrifices, it still burns out the barrel. Meaning, when you are talking about these things, these are low power, so they can last a long time. But when you're talking about big puppies, like, Russia-Ukraine war kind of big artillery puppies, yeah, those burn out as quickly, worst case scenario, as quickly as 1,000 rounds. So they're bad. And there was like a gentleman known as Hein, and that gentleman created a big boomstick. He was like, what if I can boom from here to UK? And he built that. And problem was, it was so bad at burning, they basically had to number the rounds, as in like round 1. Round 2 would be a little bit bigger because barrel was eroding that quickly. Round 3 would be even bigger. So, and we have to do all of that. Like basically boom event happens, so you get the workout without sacrificing anything, and you have to do it thousands or thousands of times, almost per hour. So it's a big problem. Basically, how the heck you seal it and still get work done without going kaput. So the basically normal average 4-stroke engine. So the first thing that it has to seal is basically the breathing apparatus, basically the air intake manifold and exhaust manifold. So it seals that using puppet valves. Now puppet valve is very ingenious because it has what we call conical pressure plates, as in it's like this. It just goes wham. Now, benefit of this is what we call pressure energized seal, meaning the more the boom event happens, the better the seal becomes, meaning it will not leak. If you have a pressure event, it's like, bro, don't worry about it. It's like, sir, we have pressure. It's like, don't worry about it. We got this. We good. We got this. You don't have to worry about it. Pressure equals done seal. Don't worry about it. That's the most amazing part. It basically takes the energy from the boom event itself to seal it. So it's really perfectly done system. That's why we don't think about it. It's like, it's done. Go home. Sweet dreams. But here's the, okay, that piston has like not a work task. It just has to seal when the boom event. But piston has to move when the boom event happens. So how the heck you seal the piston? Well, piston utilizes multiple systems, because you have to understand that piston has to be smaller than what it's supposed to be. Why? Well, while the cylinder walls are generally cooled, piston is not cooled, in contrast. So piston expands. So you generally machine the piston to be bit smaller than what it needs to be. So basically, once it starts to go boom, boom, boom events, it actually expands. That's why you cannot machine any structure into the piston that does the sealing. Sealing has to be independent. So to compensate for that, we utilize spring rings, or what we call compression rings. Now, compression rings is a specific type of metal, sometimes iron, sometimes specific type of steel alloys, that is a spring force. Basically, it compensates for the gap between the cylinder wall and the piston. Now, it's a spring. Again, to physically fit it, we have to basically cut a notch into it. Now, it has such a small surface area. In contrast to the whole cylinder and bore system, the friction that it exerts on the system, it's negligible. Like, you don't worry about it. And but it does have a break in the seal penalty. It will have some blow by. So to compensate that, we just generally rotate a second system. So there is a second valve. This has lower pressure because it's only supposed to deal with leakage gases. Because again, while the spring is there, it does rely on the pressure itself to seal better. It's still not a perfect sealing. And again, you're talking massive motion, massive G forces. So it's not perfect. So seal 1 gets the job done like 80% of them. Steel 2 gets that 80% done, as in 80% of the 80%. So it's a really well run. And then we have a third seal, which is generally there for lubrication, because again, we do not have sacrificial metal there. So oil sprays the cylinder part, piston goes like shh, oil bearing, GG, super awesome. But here's it, if that oil is left there, it will burn. You cannot have that burn. So how do you do that? You have on the top, just a very little, you have an oil scraper ring that just removes all the oil. Basically, as the combustion front event is going down, it's removing the oil before it. So oil scraper ring will remove 80%. The second one will remove the remaining 80%. So you get clean, dry, boom event. That's how we successfully managed to seal pistons millions of times in its lifetime. Surprisingly ingenious, meaning, and again, that's why it has to be cylinder. People did try to make a square system, but again, it had a corner, and corner does not like seals. So round, super elegant, super easy to seal, does work. We have this technology down to a science. It works, it's done, go home. Everything else is a pale imitation of how good this puppy seals. Puppet valve is really amazing, especially when it comes to sealing. Not really good for airflow, but epic for sealing. Sealing was like, bro, don't worry about it. Like, oh, you have a boom event. I do not care. Piston is like, piston rings are like, yeah, I can handle it. I can handle it. It's like really good. I can handle it. Now, piston, basically puppet valves became the most hated part of the system simply because it has like, basically you have a smooth pipe. GG, awesome. Air is like GG, let's flow it through it. And there is a giant blockage. Now, of course, you have a conical angle that helps it, but air does not like to have a choke point. So people did try to solve this issue by creating some elaborate geometry, which we call manifolds. Basically, if you look into the piston and crankcase, it's tiny. Like in F1 engine, it will be like this tiny. And the air breathing part would be this. So that's the whole problem. Like air intake manifold would be huge, exhaust manifold would be huge. God help you if you have turbo, then you will have turbo charger and all that. It would be huge, humongous. So engine is tiny. It's like, but the breathing apparatus is massive. Why? Because we are compensating for puppet valves interference. Basically, we are working around that problem. So people are like, okay, what if we can just yeet that puppet valve? So puppet valve causes what we call constriction flow, no matter what you do, because it itself is there in the air path. It does not get removed. Like it's not a shutter where it's like, and then you seal it. It's not like that. It's in the pathway. It's perfect for sealing, but does come with the penalty of constriction in the airflow. So the earliest attempt that was somewhat successful was 2-stroke rotary disc valves. The idea was that it was rotating. Now, why? Well, anything that is going back and forth, back and forth, back and forth, it's inherently energy wasting. Not remove the spring part, because again, the spring for sure will be returned to you. But when you're talking about inertia, like you're changing direction, it's like, wasteful. But you're spinning, you spin faster or slower. It does not change direction. It's a far more energy efficient system and less noisy also. However, they were phased out because reed valves became far more reliable and far more massive airflow capacity. So reed valves became basically the next big thing in 2-stroke, old days. However, a lot of people have been continuously trying to basically take the 2D shape and make it into 3D and make it into rotary system. And it does work. Let that be very clear. Every aspect of the rotary engine, rotary valve train works. It's known, it's tested. YouTubers are building small engines. Companies are trying to make a big engines. It works. It's a done system, like it does. And it does a seal very well in terms of compression stroke, in terms of intake stroke. It's good. It's just that the moment it has power stroke, it's like, yeah, bro, I quit. Power stroke, it cannot seal. And here's the problem with that. If you cannot seal a power stroke or like good enough seal, you have too much blow by. And if you have too much blow by, as in like any from the crank case itself or the engine block itself, they have to send that exhaust again into the engine. This is how we do positive crank ventilation. So that valve has to go into the air intake. Why? Well, so piston can suck it again and throw it out to the right pipe. What is the right pipe? Exhaust pipe. Exhaust pipe goes through the catalytic converter, so it can remove any unburnt hydrocarbon. So you can see that, like, we know this, like physics is known, science is tested. It's just that we cannot seal boom events. For small engines, it's cool, fine, dandy. But for big, high compression engines, it's like, ooh, that's the big issue. So, because they are failing to seal. And again, people are trying, what if we have this geometry and that geometry? Again, science is sorted. It's like, if you can have a sealing, basically science says, make this, have fun. Engineering says, bro, we cannot make a rotating seal that has the same oomph as, conical seating puppet valves. So yeah, that's the whole point. Everything can work as long as it seals. It does not seal, that's why it does not work. Now we come to the most desirable engine for some reason, rotary engine. Now this puppy was built by Felix Heinrich Wankel, came up with this design long ago, as in like 1924. Yeah, this is an ancient engine. And NSU was a German company. That company was now digested by Audi. That was the first car they released, NSU Spider, in 1964 in European Union. It worked, but not that great. Like, it was good, but not that, like, unbelievable. This is very early on. And Master looked into it, and for some reason, Master just like starstruck with it. It's like, whoa. They're like, whoa. Like, every child who types in the comment is like, rotary engine will be the most efficient, most this and that. Yeah, everybody in Japan, specifically in Master company, actually felt that, and they're like, we're gonna put our money and our might behind it. And they put some effort into it. Let that be very clear. You cannot say they put, oh, we're gonna license the engine from Germany. No. They took it and they refined the hell out of it. Like, they actually worked their ass off. Like, it was no longer just like, oh, we have that technology. No. They made it their own. So they put money like there was no tomorrow. And it still did not work. Now, why the heck not? Well, reality is very simple. It does not seal. It does not seal. The end. There is nothing more to talk about. Because you have to understand, it's not a cylindrical system. So you have two flat seals. They're like, okay, we can do that. But again, you are frictioning. This is how your friction is happening. It's not like this, I can believe. But yeah, no. And not to mention, the apex seal did not work. And like half of the Japanese engineering and patent is just on the apex seal. How the heck we seal it? In reality, they could not. So it has to burn oil like a two-stroke system. So they are trying, what if they have this coating and that coating? The best they have right now is they are forcing a motor generator unit to tame it in such a way that they can meet emissions, and it cannot be the main powerhouse, because again, it will emit too much and it will fail regulations. So they are like using it as a range extender. That's how far Mazda got. Like, they put money into it. Like, you cannot say that they were like, half-assing it. Like, they went all in into it, and it just did not work, because again, it did not seal. Everybody thought, oh, we can just seal it. Nah, you can't. And you must have seen like a new resurgence, which is a liquid piston rotary engine. Now here's the deal. The geometry is inverted. Basically, the involute shape is the rotor, and the triangular basically they are inverting. Basically, rotor and stator is getting inverted. Now, why would they do that? Primary reason is that if they do this, they can exceed the compression ratio. Why would you want to exceed compression ratio? This puppy could not work on diesel. Like, people try it, but it's just like, nope, it just puts on diesel. It just does not work. It does not have enough compression. This achieves it. So why they are working on this? Well, right now, especially after Russia-Ukraine war, there is a horde. There's like, people are like, take money, give me an engine that is the next Shahid drone engine, basically. They want an engine that meets certain criteria. Criteria being lightweight and powerful. Efficient? Awesome. Shut up, take money. It does not matter whether it's a long-lasting engine or not, useful or not, practical or not, polluting or not, does not matter. If you can have these three things, so there is a lot of resurgence into new weird design simply because they don't have to match emissions. So they are working on that. And again, it has the same issues, the seals. Now, they are saying it's better simply because the seals are in the body, as in the stator part rather than the rotor, so they can lubricate it better. Can they? Of course. Will it be as good as like normal four-stroke? No. But Let's see. And again, I can easily see them like army generals looking into it. It's like, you're telling me that you can give me even 10%, let's just say 10% more mileage, and power to weight ratio so high that it can actually, instead of, let's just say, your drone loitering at 10,000 feet, can loiter as 25,000 feet. Shut up, money, the end. So that's why it has some use for it. But let that be clear. If you wanna expect that like this is gonna be in my main engine, yeah, no. Look into their own site, into their own specification sheet. It's bad. Like a lifespan is 1,000 hours before rebuilds. That is low. That's low for two-stroke. That's how low it is. So, and be mindful, they have to use roller bearings because the crankshaft, as in like the rod, has the pipe which flows the air in and out. Now here's the air in and out, and that's not the big exhaust. Yeah, you can't have oil there. So yeah, that's the issue. It does work, like that system works, and I can easily see this, like, you know, being like, shut up, take money, make me as millions of copy of this as possible. But can this be the next power plant of your car? No, just no, it does not seal. So what about alternatives? Let that be very clear. You can make a new internal combustion engine even right now, even in 2025. Never let anyone tell you, oh, engines are done. No, no. We are here. It's going to be here for a very long while. So you can do that. As long as it seals, it has to seal as good as normal four-stroke engine, if not better. If it does not achieve that, just walk away. Like, don't waste time. It's like, oh, there's like, we have this engine, and it's like, it could be some niche engines. Awesome. No, who cares? Heck, there is no sealing in jet engine. It's open combustion engine. So there is a need for those things also. But if I'm going to replace ice with this ice, is like, does that ice seal? And I mean, look into the whole system. Does it seal as good as it needs to in order to compete or exceed what a normal basic pitch four-stroke engine does? So that's the first thing. Like, let's give some example. Rev Force engines, they have this puppy, and they have a very good idea. Now, like, okay, they have rotary engine. How the heck it's handling? It's not. It's a two-stroke rotary system, and the idea is that is an exhaust valve. Why they have that, I have no idea. Don't ask me. It's stupid to have exhaust valve. The best example I can figure out, like, why they are adding it is simply because exhaust gas recirculate. Basically, they want to close it so all the exhaust does not go out. Diesels like that, especially at partial load. So how the heck they're handling the combustion? The piston goes above the ports, so it's completely sealed. Then they are doing the boom event. So nothing, none, nor the port, nor the rotary valve, none of them are exposed to any boom events. So it works. It's a known tested system. Like, we have this, like, this is almost like Detroit diesel. It's done, sorted, it will work. Question is how efficient and how long lasting price performance. Those are fun part. But this is on a good condenser. Like, yeah, we can compete. Then we have CV engine, the one that I'm working with. This also has the same logic. The central part, basically the crankcase is being replaced by constant velocity motion, and benefit of that is we have lubrication. Heck, in two-stroke we can do the full lubrication like this one, but we have the another benefit. This can do what we call natural aspiration, meaning we can do two-stroke, no oil burning, without supercharger or turbocharger. That's the unique part. And again, I'm like really grinding Ron's head on this. Is like, if we can make that, I can sell that puppy to so many drone manufacturers. They're like, you're telling me that we can just dump oil like it is in like normal oil without adding, like, you know, two-stroke oil, and it will just work. And we can add turbo to it, so it can do very high altitude and it will just work. Yes. So that can be done. And again, what about sealing? Exactly normal sealing. Actually, it's a bit better sealing because it's not doing this. It's almost like how you have a diesel two-stroke where you have a connecting rod. So it's completely linear. Sealing is even better. That is done here. So seal setup is the same. So now you can have a discussion again. Hopefully by end of November, we're going to throw this engine to RE and they're going to test this for us. Then we have SciTech engine. Again, same concept. They are only tampering with the core aspect of the engine, as in instead of crank, they have Scotch yoke. Could it work? Again, steam engines used to rely on that, and it has some benefits and some pros and cons, but again, it can work. Like, you can have some attention to it simply because likelihood of this working is higher compared to any other this design and that design where the sealing is not sorted. If sealing is sorted, move on to next stage. If sealing is not sorted, don't waste time. So let that be very clear. Ice has a lot of energy left. Heck, I can give you magic battery tomorrow. Let's just call it quantum capacitor. I give you that has like 75 unit capacity in 1 liter. 75 as in 75 kilowatt hour. Yeah, that can be done. Theoretically done. Okay, I give you that. Here's the deal. You'll still not be able to use electric vehicle. Why? There is no grid that can handle that. And please, for the love of God, do not give examples of tiny countries. Always give example of top 10 countries in terms of population, and you will notice something. Population is going down drastically worldwide. 150 countries are below replacement level, as in below TFR of 2.1. They did, and still oil consumption are going up. And still, why the heck EVs are there? EV is not there. We are just subsidizing it. Ironically, we are subsidizing EV in India specifically by oil revenue. I'm like, bro. And again, China has EV. No, they have what we call a new energy vehicle program. Billions of dollars, not 1 billion, billions of dollars was poured into it. The moment they shut off that tap, everybody switched to hybrid. It's like, yeah, it's not happening. USA, billions of dollars for charging infrastructure. I'm not even going into how much they are giving for the companies to like, okay, build a plant and this and all that. It's like, yeah, it's a lol. So fundamentally, if anybody says, oh, ICE is done, no. At least for next 50 to 100 years, we good, we got this. And certain things just can't touch with batteries, even if you have magical battery, specifically anything that flies. So there is a lot of room, there is a lot of scope, but again, make sure the engine seals, only then we can have a discussion. So this was my presentation on the new and unique engines and their sealing problems. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.